Understanding sustainable materials. Integrating sustainable materials into engineering designs involves selecting materials that have minimal environmental impact throughout their life cycle. These materials are typically characterized by their durability, low energy consumption in production, recyclability, and reduced carbon footprint. Understanding these characteristics is essential for making informed decisions about incorporating sustainable materials into engineering projects. Assessing material sustainability. The first step in integrating sustainable materials is to assess their sustainability. Evaluate materials based on criteria such as renewable resources, energy efficiency during production, and end-of-life disposal. Consider materials with certifications such as LEED, Leadership in Energy and Environmental Design, or Cradle to Cradle, which indicate adherence to sustainability standards. Additionally, research the environmental impact of materials from extraction to disposal to ensure they meet sustainability goals. Selecting eco-friendly materials. Choose materials that align with sustainable practices. Options include recycled materials, such as reclaimed wood or recycled steel, which reduce the need for new raw materials and minimize waste. Other eco-friendly choices are rapidly renewable materials like bamboo and materials with low embodied energy, which require less energy to produce. Ensure that selected materials offer the necessary performance and durability for the specific engineering application. Incorporating materials into design. Integrating sustainable materials into the design process involves considering how these materials fit into the overall project. Analyze how their properties, such as thermal insulation or structural strength, affect the design and performance of the final product. Ensure that the materials are compatible with other components and meet the required safety and performance standards. Sustainable design often involves balancing environmental benefits with functional requirements. Enhancing energy efficiency. Use sustainable materials to enhance the energy efficiency of engineering designs. For example, incorporating high-performance insulation materials can reduce energy consumption in buildings by minimizing heat loss. Similarly, using energy-efficient materials in manufacturing processes can lower the energy required for production. Consider materials that contribute to passive design strategies, such as natural ventilation and daylighting, to further improve energy efficiency. Implementing circular design principles. Adopt circular design principles by selecting materials that are designed for reuse, recycling, or composting at the end of their life cycle. This approach reduces waste and extends the lifespan of materials. Incorporate modularity and disassembly features into designs to facilitate easy separation of materials for recycling. Circular design promotes the creation of closed-loop systems where materials are continuously cycled back into use. Collaborating with suppliers and manufacturers. Work closely with suppliers and manufacturers to source sustainable materials and ensure they meet environmental standards. Establish partnerships with suppliers who prioritize sustainability and can provide information about the material's environmental impact. Collaborate with manufacturers to explore innovative processes and technologies that enhance the sustainability of materials and their production. Evaluating life cycle costs. When integrating sustainable materials, consider not only the initial costs but also the life cycle costs. Sustainable materials may have higher upfront costs but can offer savings over time through reduced maintenance, lower energy consumption, and longer lifespan. Conduct a life cycle cost analysis to assess the long-term economic benefits of using sustainable materials in your design. Testing and validation. Test and validate the performance of sustainable materials to ensure they meet the required specifications and standards. Conduct rigorous testing to evaluate durability, safety, and functionality. Validation helps ensure that the materials perform as expected and contribute to the overall success of the engineering design. Educating and training. Educate and train design teams and stakeholders on the benefits and application of sustainable materials. Provide resources and training on sustainable design practices and material selection to enhance understanding and implementation. Promoting awareness and knowledge helps integrate sustainability into engineering designs more effectively. Conclusion. Integrating sustainable materials into engineering designs requires careful selection, assessment, and application. By choosing eco-friendly materials, enhancing energy efficiency, and adopting circular design principles, engineers can contribute to more sustainable and environmentally responsible projects. Collaborating with suppliers, evaluating life cycle costs, and validating material performance are key steps in ensuring successful integration of sustainable materials into engineering designs.